a new edition of the Heat Treat podcast. Today we have a power player from the industry from Europe. I believe you're based in Austria, Thomas. Thomas Dopler, Chief Technology Officer of the Ikelin Group. Good afternoon for you. Good morning for me. How's it going, Thomas?
Hello, Carlos. Nice to meet you. And yes, it's going well here in Austria.
Fantastic. Fantastic. Glad to have you here. Super excited. Today, we're going to talk about how to go green on heat treat, burner technology, how burners that we use nowadays are doing, how they, I guess, contribute to global warming and the greenhouse emissions, which is a very controversial topic nowadays worldwide. But we're going to apply it to heat treat. And before we started recording the podcast, like the main topic, Thomas is Chief of Technology on a very big group, I believe the biggest group of furnace builders in the world. And he's saying, okay, we have to go green. We're going green. And this is going to be a great discussion. But before we do that, Thomas, can you just give, a brief introduction of the Ikelin Group and your role on it and your career? I saw your CV and it's really quite impressive. You've been in all positions, and now you're Chief Technology Officer for the whole furnace division. But who is better to give us an introduction better than yourself? So please.
Yes, thank you, Carlos. Thank you for me being able to be here with you and record something for our auditors. So, yes, my name is Thomas Dopler. So I'm from my basic training, I'm a material science engineer. So I studied material science a long time ago now. And so nearly 30 years, much more than 30 years now even. And so after my studies, I was able to do a PhD. I had a PhD, also material science, and then started working in the industry. I started working in the aerospace industry. We were a supplier for aerospace aluminum extrusion, so aluminum and aerospace. And then afterwards, I changed to the steel industry. So I joined the Austrian steel gigant voestalpine, who is the biggest Austrian steel producer. And I've been working for them from 2002 to 2008 in various positions overall in the automotive business. So this got to know me in the automotive business. And afterwards, one of my projects there was to work on hot stamping, which means automotive parts, body in white parts, which pass through a furnace are then hardened in a press. And this was my entrance, in fact, to come to Ikelin. And I joined Ikelin now 13 years ago in 2008. And between 2008 and 2022, I've been working for Ikelin in various positions. Between 2014 and 2021, I was heading, I had the responsibility of the Mödling plant, which is the Austrian plant of the Ikelin Group. And since quite 1 year now, I am part of the Ikelin Holding. I'll say some words about Ikelin afterwards. So the Ikelin Holding is the holding organization of the Ikelin Group. And there I have the responsibilities of a little bit more, let's call it the future topics, which means we are a little bit into digitalization industry. We call it in Europe, we call it Industry 4.0. And overall, the big challenge, which is ahead of all of us, which is decarbonization, going green, climate change. And so this is where I'm working now. In a small part of my job, I also work for a mother company of Ikelin, which is the Berndorf Group. And there I had the innovation and technology company. They have a small innovation technology company, which is funding R&D projects for future applications, also for the Berndorf company.
So today, the topic we're going to cover is a little disruptive because we have been burning fuel, we have been burning gases for many years, and that's the way we have done it. And right now, with all the global warming, you talk a little about digitization, but it doesn't have much to do with this. It's another like big trending. but today we're going to focus on greenhouse emissions, global warming. So we do heat treat, right? We heat stuff to very high temperatures, and we heat thick stuff, heavy stuff, and we use a lot of energy. The best way to perform that up to date has been burning fossil fuels, natural gas, propane. As some applications they use electric, to heat furnaces. But I believe, well, and I'm based in North America. I'm based in Mexico, but the main energy source has been natural gas for high applications. But that saying that we contribute to greenhouse emissions and global warming, right? If we go and try to analyze the very basics of combustion, we need to have an oxygen source, a fuel source, which in this case will be natural gas or propane, and some heat or a spark in order to have the chemical reaction. So that's combustion 101, but I'm just an engineer and you're a PhD, right? And now we've been using natural gas and propane. You are telling me that you want to go green. How can we go green on the heat treat industry?
Yep, I'll answer on this immediately. Okay, so maybe we start a little bit more general. We are doing classically, or most of our companies, our customers are doing heat treatment on steel. So classically, if you look at steel, you have the steel production, and this is already a very energy intensive production. So steel has incorporated a lot of CO2 and other gases already during its production. And then what our business is, and what your business is, what the business of our listeners is classically, is a secondary heat treatment. So you do, as we said, case hardening, you do classical oil hardening or things like that. So as you said, we have a part of heating up. We know it in degrees Celsius up to 800, 900 degrees Celsius. Then quenching, and then classically, or heating up, and then have the carburization, and then quenching, and then maybe some tempering. But the biggest energy impact, as you said, is during heating up to 900 degrees Celsius, plus then adding some carbon into the surface of the material. Let's say it like this: the classical case hardening process. So, and for that, these two processes, heating up and having the atmospheres, can be reached with different means. Let's start with heating up. It's just to bring in the energy. Classically, our ancestors did this. They had some coal fire or something like that, or some wooden fire, which is, in fact, the most dirtiest kind of heating up.
Carbon and wood.
Carbon and wood, yes. Today, we have classically natural gas, which is the main source for heating up. Natural gas is chemically, it has a certain impact while burning. Alternatives are to have some biofuels, or to go into hydrogen or into electrical heating. So this is a little bit the different possibilities that we have. And so the important question for everybody is, how do we choose? What should be the best way to do it? And there, classically, the answer is, unluckily, it depends. It depends on what, and that's I think we go on further in this discussion. The global aspects, maybe some words about Eicheline before we go into that. The Eicheline group, as I said, is one of the biggest heat treatment groups heat treatment equipment groups in the world. And we have a global footprint because we have units in the US, you know very well, AFC Holcroft. We even have some people know less well. We even have some heat treats, so commercial heat treats, part of our group in the US. And we have units in the rest of the world. the headquarter being situated in Austria, but also units in Germany, units in Switzerland, units in Slovenia, units in France, and we have units in Asia, in India, and in China. And all these units, they have the same issue, but the question or the answer to this issue may be different. Why? You have economical aspects. Economic aspect is cost. So how much does the energy cost that I want to bring into the furnace or into the material? That's the first point. The second point is ecological. So the second point is the energy that I bring into the material clean or is it dirty? So that's the second aspect. And the third aspect, which is overall now becoming more and more important if you look at the European political situation actually, is availability of the energy. So do you have a secure availability of gas, of hydrogen, or of electricity? So these are a little bit the three main aspects you have to take into account: cost, ecological aspects, so cleanliness of the energy, and availability.
And base it around the world. I mean, you said it has to do with geopolitics and geographical location. You know, Asia, Europe, and North America, they're very different from each other on costs, availability. Yep. But it's all about, it also has to do, and there are some countries with further ecology normativities than others, right?
Yep.
How do you envision this industry to change? We know that it's going to be a disruption. The electric car is coming. There's more awareness that we need to become more green, right? But there's a bunch of equipment in there, functional, that is still being built nowadays, right? It was designed to run with natural gas. So we have massive loads on units that are going to still be using natural gas.
Yes.
How is that going to be the change? Will those be new furnaces, or those furnaces will be available to upgrade their combustion system to this more greener technology? And regarding the ability, can you explain us first what do you have in mind regarding that? And if you just could tell us a little how hydrogen or biofuel works on a furnace, on a heat treat furnace, and let's choose just an application. Let's say a hardening furnace. How will that be performed around the world, right?
Yeah. Okay. I want a little bit to go into more detail, maybe just on the three aspects that we discussed before, on availability, for example, and cost. If you look at North America, which is the main market we are talking in the context with the Heat Treat podcast, North America has the big advantage that gas is really available at a very reasonable cost. So, and there are no negative taxes from the cost side on the CO2 emissions. So for North America, gas is a very interesting alternative also for the future. But nevertheless, what you can do is to work more and more on the efficiency of your heat treatment equipment. And so these are aspects that can go on every day, which means you take carburizing processes, you have the carburizing gas, you can have it in several levels, which means you start with high level, go down to low levels. So that's the first thing of economy that you can do. The second thing of economy that you can do, have highest efficiency burners, because burner efficiency in the last 50 years has strongly increased. We started, I think, in the 1970s with an efficiency of 50 to 60%. Nowadays, also some advertisement for our daughter company, Noxmart, we can go up to 80, in some cases even to 90% of efficiency. And so you can use twice as less gas as before if you upgrade your burner system. So this is one of the things. Second thing for efficiency is you can try to re-insulate your furnaces. So the insulation you can upgrade, because in the last 20, 30, 40 years, insulation development has been going on, and the efficiency of the insulation has increased also strongly. So you can have less losses, heat losses through the walls of your furnaces. And then you still can try to work a little bit on the processes, which means have maybe a little bit less, lower temperatures or things like this. So work on the process itself. So these are different possibilities that you can do in also with your existing furnace to upgrade the systems to make your furnace more modern. Now, other alternatives, if you use classically endogas today, you can also use, for example, biofuels or biomethanols. These are some things which just start being developed in the European market. So some of these fuels start being available. And so then you can have a green tip on your on the fuels you use. But again, we come to the second point. It's about cost. So if these fuels are still 2, 3, 4 times more expensive, then it will be not so easy. There we come to the cost topic, which is a very common topic in Europe. Our customers choose very often between electric and gas heating. What are the reasons that they choose? In some countries in Europe, electrical energy is now really not much more expensive, let's say it like this, than gas. I named just 2 countries in Europe, which is Sweden and France. France has a huge park of nuclear energy available for the customers, for the producing industry. And Sweden, Norway, the northern countries, also a little bit Austria, have a lot of hydroelectric power. I think that's the right word. So we have a lot of hydro stations, and we can use this energy at a relatively reasonable cost. And many countries start to invest more and more into wind energy and solar power. And this is also very strongly supported by fundings overall in Europe. So in Europe, you have the discussion to choose between gas and electric, and it depends on your specific application. Do you want to have something really green? Also, do you have access to green energy at a reasonable cost? That's more or less the choice that you have now sometimes in Europe. If you look on the other side of the world, so far away from you and far away from us, so to the Asian market, there often it is still about availability. So many furnaces there are today electrically heated. Why? Not because the energy there is very clean, but because they have the availability. They have a lot of coal stations, power stations to produce electric energy. But this energy, we have to be really frank, is neither clean nor really cheap. So this is, in fact, on my opinion, the worst case.
And
so,
I gotta make a stop on there, an observation. Also, heat treating, it's a geographical business. If your customer is in the middle of somewhere, you have to have your heat treat shop close to it, because there's going to be a bunch of material back and forward. And so sometimes you don't choose the area your customer is going to land. And what you just said made a lot of sense. Then you gotta put your furnace and see, okay, which energy I'm gonna use depending on the availability. So you're totally right.
Yeah, exactly. And in fact, this brings also now the which energy can be best transported. You can have electric power lines, so electricity can relatively well transport it. And there comes a little bit in one of the alternatives, which is hydrogen, because hydrogen can be produced and can be transported rather easily. So this is also where hydrogen comes in. But I want already to say something about hydrogen. You have to produce hydrogen classically from electrical energy.
Okay.
And hydrogen has an efficiency. So you lose some part of the electric energy when you produce hydrogen. And so in general, if you have the choice between doing an electrically heated furnace or a furnace which is powered with hydrogen made of electric energy, then it's always more efficient to use the electric energy.
Okay.
And there we come a little bit to when you want to upgrade your furnaces to electric energy, that's something where we and Noxmart has solutions. So what we do now is we try to have a solutions where you can just put out your burner out of the radiant tube, and then you put in the electrical heating element. So this could be the easy way, but nevertheless, you need also the electric power available at the customer's plant. So this is there again, you can exchange it easily, but you need the power plug with the megawatts that you need for the heat treatment.
And I gotta ask you on that because there's all, I have very little experience with electrical heated furnaces because I just say like France is big and well known for nuclear power plants, right? But in the case, and let's take just more North America as the example where gas is very available, right? Relatively cheap. I don't want to say cheap because costs are going up, but it's cost effective. Let's say cost effective, right? And you got nuclear power plants.
Yep.
Do you see a balance in there depending on the application? It's mainly, as you say, mainly it's 950 degrees Celsius what we use around 2000 Fahrenheit. So with the trends that everybody's going electric, do you envision, let's say, because your job is to envision to the future, right? In 50 years, are all furnaces going to be electric, or they're going to have to be upgraded to a different system? You mentioned hydrogen and biofuels, because when you have natural gas, you got fumes, you got exhausts, then you got dirt, you got a lot of soot, right? And when you use energy, like electrical energy, you don't get soot, you don't need a gas exhaust, but it's more expensive if you don't have a nuclear power plant. So it makes sense from a ecology point of view. The process is cleaner, but we're in business and it's all about costs, right? And now costs slash taking care of a planet. But what's your ambition? How it's going to be the furnaces in 50 years?
Yeah. So what I see, it's the tendencies that we see already in the European market. Gas will be still a strong player. So some of our customers still buy gas heated plants. Also nowadays, they invest into new gas heated plants. But the part or the share of the market going to electricity is going up more and more. And I think it will be, both will be there, but with a little bit of share going more up for the electrical heating. For the hydrogen, as I said, I think there's still a little bit less application. But the advantage is you can adapt. So it depends on how the taxes, how the government subsidiaries, all these things develop. And that's what we discuss classically with the customers. How do you imagine your gas price going up? How do you imagine your electricity price going up? From when will you have green electricity in your plant available? From when will you have maybe hydrogen available? Also in hydrogen, I'm not sure if you know, there are different colors of hydrogen as well. Can have green hydrogen or brown hydrogen. So and between there's a spectrum, blue hydrogen, there's red hydrogen. So you have really all the choices that you want. You can play nice color games in this case. But so it depends on how this will be available on the different places of the heat treatment.
So what I'm getting from this conversation is that you believe gas is gonna have uh, a role in the future still. You know, we are not gonna get rid 100% of gas, but we can have a mixture, right? I'm envisioning saying, okay, let's say you have your carburizing furnaces running on a more efficient burners using natural gas, but we can have tempers, your generator, with on other applications using electricity. So we will lower the demand of natural gas, but it's gonna be still a part of our process. Did I understand it correctly?
100%. As I said, you can even imagine, and that's what we sometimes discuss with our customers already, two variants. First variant that you have as in a car, you could have a hybrid furnace, which means
hybrid furnace. There you go. You have to have just nail it.
So you can have hybrid furnaces where the heating up zone is still efficiently gas heated, but during the holding zone, you can work with for example, electrically heated.
Yeah.
Or the other way around is that you have both. So you can have a furnace upgrade changing easily from gas to electricity.
You hit the nail. You know, right now the market, it's all not the way to electric. I'm talking about cars, by the way, but you know, hybrid cars have gone up significantly. So I just got it from you. Furnaces are going to be hybrid, ramping up. From ambient temperature to 950 degrees C takes a lot of energy. Is very intensive of energy consumption. But once you're there, you can maintain and just pick up, pick down a little bit, and you might even have a better PID control with energy, because it's a little more. You can control it a little better on detail, right? Did I get it right, Thomas?
Perfectly, yeah.
Okay, right. Well, now I gotta say, nevertheless, even if we have the best hybrid system or the best or a newest technology on burners, if we do not have a furnace well maintained, if the insulation is not in a good state, if we do not calibrate our burners to the right amount of oxygen and fuel, it's going to be useless. Yeah. I go to many shops, many big companies, and they want to have a retrofit. I say, I want to have more efficient burners. And my answer to them is, you don't need more efficient burners. The first thing you need to do is to change your insulation and then calibrate your burners. Then measure that. And after you measure that, you start thinking about buying a new combustion system. But I believe this is one of the first mistakes company makes. I want to reduce cost, I need to change burners. But you see that their insulation, it's very deteriorated, and that they don't take good care of the burners, calibrating those. Do you have an opinion on that?
Yes, no, I agree 100% on what you say. And this could even, as we call it, quick wins. Could be quick wins, because that's something where you do not even really need to invest a lot. You just have the burner company come, reset up your burners, or you have replaced them also by more efficient burners, keeping the same radiant tubes. Or on the other hand, just when you re-insulate your furnace, what you should do every 10, 15 years, then not use the same old insulation stuff, but go to a highest class insulation, which is not so much more expensive.
And now, after we do this, now let's focus back on the new burner technology. After we do this, and we got our burners that, let's say they're 10 years old, right? We switch insulation for the first time, right? We calibrate those. I find it also very interesting that people do not have to measure how to measure their energy cost. They just take their bill, right, and say, it cost me $10,000 or 8,000 euros, right? I wanna have some savings. That would be like a plan manager way to decrease cost, but the study is way deeper at the furnace, at the workplace. How would you recommend to perform a study on how to measure the gas, the temperature, to get the real number of energy cost that you're getting from the forest, which I assume you have done the studies many times.
Yeah, yeah. As you said, it is important to know what you do, and that's in Europe. The tendency goes there for the last 10-15 years, because in Germany, for example, some of the tax reductions, you only get them for energy if you can prove and if you can measure for every equipment, every furnace that you have, that how much does this furnace consume, both gas and or electricity. So you have to measure this permanently. If you take Bodycote, some of the world's biggest heat treatment, they know at every furnace how much, at least in Europe, how much it consumes. They can tell you every day because they have installed sensors, throughput measurements. They measure the gas that they consume every time, all the time. And I think that's something which will come also a bit worldwide. First, be aware of what you consume, and then start testing one or the other modernization. One furnace, you modernize it, the other ones, you change the burners, and you measure what you get from it. You measure the quantity of that you can spare if you do this. And that's step by step. And that's what I also mentioned at the beginning. It's a little bit of some kind of industry 4.0 light. You just start measuring, knowing your furnace, not only by feeling it, by hearing it, but by also measuring some of the values that you need, consumption, but also the functionality values.
So when you say sensors, you mean like a totalizer on the gas pipe inlet?
For example, yes, you can vibration sensors or things like this, temperature measures, because you have the waste gas. And that's also some way to spare some energy. The waste gas, classically, you cool a little bit down with fresh air. Otherwise, you can have the risk of putting fresh air into the furnace. So you have some pressure on this. And the waste gas has also some temperature, some energy. And some customers say, okay, let's use this energy that you have in the waste gas and heat, for example, the washing agent. And so this is something which you can do also. And this is a little bit know what the temperature of the waste gas is, then try to have a heat exchanger, and then with this heat exchanger, heat other equipment which has to be heated.
So if we could just summarize your recommendations in order to reduce energy. What would be like the most important for nowadays before upgrading burners? What do you think are the most common mistakes that could save energy for actual users before upgrading their systems? What would those be?
The first thing, I think the first thing is what you have to know what your furnace does. So it's a process know-how, let's say it like this. So where do I need, for example, the process gas, and where I do not need it? And there you can then say, okay, let's change the settings of the furnace for the periods where I need and where I do not need. Look, for example, at weekend periods. Many customers keep their furnaces hot during weekends, even if they do not work. The question is, does this make sense? And it depends. Again, it depends. Do you have closed down for 24 hours? Do you have closed down for, let's say, 1 week? And there you could have different recipes, because it takes a certain time, we know, to heat up a furnace again. But nevertheless, depending on how long the pause is, it could make sense to cool the furnace down, maybe not to 0, but maybe to 700 degrees, and start at, say, Sunday night to heat it up again. So this is know exactly what to do, and know the impact on the energy consumption.
Okay. Uh, the easiest way to measure, let's say there's a commercial heat treat that doesn't have sensors yet. How could they start begin to measure what they do? They have different furnaces on a different stage of maintenance. Some of theirs are newer. They may have different burner technology. Maybe some of them have car bottoms or pits or IQ furnaces, you name it. What would be like a second step just beside looking at the gas bill?
I think have a gas consumption measurement on each furnace. That is something, the first step. The gas measurement is not so expensive anymore, and this can be easily be introduced. In Europe, it's already mandatory for some countries if you want to have a tax relief on this. And I think this could be also a good step for the S. Start measuring the energy on each furnace, and then you see immediately, for example, furnace A consumes more than furnace B. It's older, it has less efficient burners, or the insulation starts to break down. This is something which you can easily measure if you have the same processes running into furnaces.
Okay. And what about furnace burner performance? How can you tell if your burner is working correctly, right? Or when you need an upgrade already, saying like this burner is not functioning correctly, I'm actually spending more money than the one I'm getting, I gotta change. When is that tipping point? Because burners can last a bunch of time, and you see the flame, you see the heat, but how can you tell if a burner is obsolete if you're not measuring it?
Yeah, that's a good question.
Yeah, I know. And I believe I'm asking it to the right guy. Because this is Thomas, because this is the reality. I visit many companies, and you see the burner system, their combustion system working, right?
Yeah.
And there's the belief that if it's not broken, why fix it, right?
Yeah.
But you might have a functional obsolete burner that is making you lose money. But how can you tell? We talked about measuring it. We talked about calibrations. We talked about all that. But if it's well maintained, but the burner is 60 years old, it's gonna still continue to run. But how can you tell if your system is obsolete if you don't have any of this? Or you can't? Maybe you can't.
You can. There's some indications, nevertheless. So you see if the burner is on and off. So that's the first thing. You have also to distinguish between open burners and burners with radiant tubes, because one question is, how do you see that the radiant tube is broken? So this is, for example, one question. During maintenance, often there may be some problem with the radiant tubes if they are ceramic or if they're metallic. So if they're metallic, they can start to bend. If they're ceramic, they can break. So this is something which you feel or which you see nevertheless on the furnace, on the atmosphere, if you have this topic. But one indicator nevertheless is look at the heat, at the waste gas of the burner. So if you have the recuperator, if it is really red from the color, so then you have I think you have a topic, because then the burner is too hot, or the recuperative gas is too hot in this case. So these are some indicators. If these are too hot, then there might be some issues with the burners. Nevertheless, if you really want to know, I just recommend use some guy of a burner company, and he's a specialist. He will tell you immediately. He looks on some of the measured values on the burner itself, because there is some PLC in the burner each, and you can you can have a quick analysis, and you can really say this burner is working the right way or not.
I get that a lot, that if the burner is working right or not, but some burners might be working right, but using a lot of energy, right? That the new technology. But Thomas, it's been fantastic talking to you about how the industry is gonna go. Always like to talk about technology. Do you think we missed something, or would you like to add something else before we close the show? regarding this topic, of course. Just
Yeah.
burner technology.
A little bit summarize in the way. So the positive point about furnaces is that you can use every kind of heating. So you can use gas heating, electric heating, and hydrogen, or you can use biological fuels. So it's about cleanliness of the energy, cost, and availability. And I think these three you always have to ask each other. You have to put them together and then decide on what to do. This goes also together worldwide now with when you say cleanliness of the energy itself, but also cleanliness of the product of the energy, which means when you heat electrically, how many CO2 you produce, because in Europe you have to pay taxes already for this. And maybe one day this could also come to
everywhere else in the world.
to the rest of the world, yes?
Yes.
So this is, from my opinion, this is the most important thing you have to take into account. And then you decide, upgrade the furnace or even buy new equipment with different heating, or upgrade the burner system or the heating system. Let's say it like this. And then we are lucky to support our customers in doing this in Europe and also worldwide.
Thank you so much, Thomas. Now, for the closing of the show, you're a PhD. You've been you're in a technology position on the heat treat industry, and by talking to you, you seem very passionate about what you do, the heat treat industry, and you're looking to make an impact on the world. On this trending topic, which is global warming, of course, cost savings, but besides all the technical stuff, you've been in this industry for quite a while, right? What would be something that you would like to share with the new generation of engineers that are thinking about an offer they got on a heat treat company to design furnaces, or even on the combustion sector? If somebody's watching in the combustion industry, they're related to energy and heat. What will be something that you would like to share with those guys that the new generation of heat treat, it might be a heat treat engineer that it's climbing the ladder, is getting experience, that you would like to have known when you started your career?
Good question, and maybe let's answer it like this. What I would give as a young myself, or what I would give, for example, to my son, who is now age 16, something like this, is just several kinds of advice. First, be open, open your eyes, listen, try to look, not only locally, but try to be open, because so now you may have you have local approaches, but in China it may be different, in America may be different, in Europe it may be different. Be open, be flexible sometimes, because that's also one constant thing. Even if heat treatment is a very ancient business from the old Greeks or even before up to now, one constant is nevertheless, you see it is changing, and the specifications are changing, the constraints are changing. So you have to be aware that maybe the specification of the next heat treatment equipment is different, and try to find solutions, try to be open, try to be global, flexible. I did it in the past when I was young. I also went to another country, tried to go somewhere abroad, see how Mexico is doing, because they have some great heat treatment and some great expertise there. Worldwide, also in China or in the US and in other countries in Europe, you have this expertise. Try to be part of this global, a little bit changing, but actively changing world, and contribute to this.
Thank you so much, Thomas. It's been a pleasure talking to you. You heard it from Thomas Dopler, Chief Technology Officer from the Ikelin Group. I believe one of the most influential persons that are going to disrupt this industry and are in charge of innovating our heat treat industry. So, Thomas, you have a lot of weight on your shoulders. you are one of the key players that are going to drive how this evolves. So please keep doing what you're doing. I do appreciate so much you took the time. I know you have a busy agenda. We're doing this on a Friday, and I have Thomas working on overtime. So thank you so much, Thomas. I just would like to remind the audience that we're interviewing the power players of the industry, technology guys like Thomas, process guys, commercial heat treaters, further designs on the Heat Treat podcast. And we'll see you in a couple of weeks with another power player of the heat treat industry. Thank you so much, Thomas. Have a great weekend.
Thank you, Carlos. Have a great weekend too. Thank you for taking the time.